Welcome back, geometry students. Today we're going to be talking about 10.2, area of trapezoids, rhombuses, and kites. So the first shape we have is a trapezoid. I hope you guys notice that a trapezoid is composed of several different shapes. Now I'm not going into the derivation of where the formulas come from, but I'm just giving you a quick synopsis of why the formulas are somewhat the way they are. So if you look at the trapezoid, you can see that there's two triangles and there's a rectangle that you can draw within them. Now some trapezoids may only have one triangle, but due to the definition of a trapezoid having only one set of parallel sides, you're going to have some sort of triangle in there at all times. So a triangle or trapezoid may look like that, which would be only one triangle, but I hope you guys get the idea. There is a triangle within a trapezoid. So it's no surprise that our trapezoid formula will look a little similar to our triangle formula. So we have area equals 1/2 times base 1 plus base 2 times the height. So we have the two bases added together, so let's go ahead and draw these in. Okay, I don't need these lines anymore. Be very careful erasing these. Okay, so where is my base 1 and base 2? Well, base 1, it doesn't really matter which one you call which because you're just adding them together anyway. So you could call base 1 the bottom one, base 2 the top one, and then the height is important. The height needs to be perpendicular to the bases. Okay, so if the bases are parallel to each other, which they need to be for a trapezoid, then if it's perpendicular one, then it has to be perpendicular to the other one. So your height is always the perpendicular segment to the two bases, okay? So that's your height. And then we'd multiply by 1/2 after we add those together, okay? Rhombuses and kites, a little bit different. Okay, so if I draw diagonals here across both these shapes, okay, you'll see that we create a lot of triangles here. So it's no surprise that the area of a rhombus or a rhombus, as some people say, or I don't know. Honestly, I don't even know which one who to side with on this one. The area equals diagonal 1 times diagonal 2 times 1/2. Or some people like to write area equals diagonal 1 times diagonal 2 divided by 2. And again, because there's triangles, you can see where that divided by 2 comes from. Okay, because we already showed that the area of a triangle is half a rectangle. So that's where that's why the formula looks the way it does. So here we go, the first example. Well, one, we'd need to be given some additional information. We probably would need to know that. But let's just assume this is a trapezoid and we're asked to find the area. So I'm going to call 10 my base 1. I'm going to call 8 my base 2. And because this is perpendicular to base 1, I'm going to call this my height. So I'm already ready to input all this information. So my area equals 1/2 base 1, 10, plus base 2, 8, times my height, 7. So my area equals 1/2 times 18 times 7. That's the same thing as 1/2 times 18, which is 9 times 7. And that is 63 units squared. So that is my area for my trapezoid. Pretty straightforward. Okay, another straightforward example, we have find the area of kite MOPS. Keep in mind that our diagonals are the sum of both these segments. So it'd be 2 plus 5 and 3 plus 3. So diagonal 1 would have to be 3 plus 3. We'll call that diagonal 1. Diagonal 2 would be 5 plus 2, which is 6 and 7 respectively. Now we know that our area is equal to D1 times D2 divided by 2. That is 7 times 6 is 42 divided by 2. Area equals 21 units squared. I don't know why that zoomed up. Units squared. Two really basic examples for the trapezoid and the kite. So nothing too much to report there. But stay tuned next time when we take on section 10.3, the area of regular polygons.